Hi everyone, welcome to the second part of our video on sketching parabolas using the quadratic formula and the discriminant. Now, in the previous video, we looked at this idea of finding the x-coordinate of our turning point, and we found this to be the expression minus b over 2a, where this b and a are just the terms in the general form of all quadratic equations, where for the particular ones in question, the questions we're doing, we are going to just find what the coefficient of x squared is, this a, and what this b is as well. So we came to this particular formula of finding the x value, and we got this by averaging out 2 points on the quadratic formula and then simplifying to get this nice expression for x. Now, what we're going to do in this video is we're going to take this along with the quadratic formula and the discriminant in order to sketch some parabolas. And we're also going to be using this thing we talked about to find the turning point as well. So let's jump straight into a question here, because I did a lot of talking in the last one and I just want to get straight into doing some examples here. So we have this equation of a parabola y equals 3x squared minus 6x plus 5, and we're going to do this in parts and just use all of the things we know so far. Now, for part A, this question asks us to determine the number of x-intercepts. Now, in the previous video and in many others, we looked at x-intercepts in terms of solutions to the quadratic equation in question. Because remember, our equation, we want to find the x-intercept when y equals to 0. So we're going to do, for example here, 3x squared minus 6x plus 5 equals 0. Now we need to be mindful here, because the question's not yet asking us what the x-intercepts are. It's asking us the number of x-intercepts. Now, there's a particular thing that tells us about the number of solutions to a quadratic equation, and in other words, when we look at this with a parabola, the amount of x-intercepts it will have. And this thing is the discriminant. Now, we defined the discriminant a while back as equaling to b squared minus 4ac, and different values of this discriminant produced different numbers of solutions to my quadratic formula, or number of x-intercepts if we look at this in terms of parabolas. Now, what are we going to do here? Well, we're just going to substitute our a, b, and c into my formula for the discriminant, and this will immediately tell me how many x-intercepts I'm expecting to have. And this can be a really useful shortcut sometimes, because we can have a range of different numbers of solutions, either none, 1, or 2, and taking that extra second to just consider what the discriminant is telling us can give us a real heads up on how our parabola may look. So substituting these in, I'm going to get minus 6 as my b, all squared, minus 4 times 3 times 5, and that's going to give me negative 24 once I substitute that in a calculator. Now, we found here that the discriminant is less than 0. And what does this mean? Well, when my discriminant is less than 0, that means therefore I have no solutions or x-intercepts. Now, taking this extra second means we don't even have to substitute into the quadratic formula, because our discriminant tells us that the number under the square root sign, this negative 24, that's going to produce a math error when we put this into our calculator. This is going to give us no real actual solutions here. So before we even think about what this parabola is doing, or about what its intercepts are, we can determine right off the bat that there are actually no x-intercepts at all. So that's part A here. For part B, we want to find the y-intercept. And we get this when x equals to 0. So we just want to sub in 0 into all of these x values here. So my y is going to equal to 3 times 0 squared minus 6 times 0 plus 5. So these guys here, 3 times 0 squared gives me 0, 6 times 0 just gives me 0, and I'm left with a y-intercept of positive 5. Cool, so we have, so far, no x-intercepts and a y-intercept of 5. And now just for our third part, we want to use my x equals minus b over 2a, what we derived in the last video, to determine or to find the turning point. Okay, now for this, we just want to sub in a value of b from my equation and a value of a. So writing out my equation again, that's y equals 3x squared minus 6x plus 5. And here we have to be careful of our signs, but I have my b here and I have my a here. And I'm going to substitute those in to find the x coordinate of my turning point. And then we're going to figure out how to find the y coordinate after that. So substituting this in, x equals to minus, now here my b is negative 6. So we're doing minus 6 over 2 times 3. And this is just going to give me positive 6 over 6, which equals to 1. So that means that my x coordinate of my turning point equals to 1. Now, how do we find the y coordinate? Well, we just sub in that value of x into here in order to find my y coordinate. So what I'm going to do is I'm going to say, okay, my y equals to 3 times 1 squared minus 6 times 1 plus 5. And that is going to give me a value, a y value of 2. So therefore, my coordinates of my turning point, TP, is 1, 2. 1 in the x-axis, 2 in the y-axis. So that's all for question 1. This is just using the steps that we learned. We're going to apply everything we've done here to the last question of this video, which is a tough kind of multi-step question, and it involves actually curve sketching too. So we can use everything we've done and actually come up with an idea of what this curve may look like. Okay, so we want to sketch the graph eventually of y equals to 2x squared plus 4x minus 3. And to do this, we want to label all the significant points. So my x-intercept, my turning point, my y-axis, and we want to round my x-intercept to 2 decimal places. So 2 decimal places. Okay, now we are going to systematically find all of the important bits. So first, let's find my y-intercept, because that's typically the hardest, the easiest thing to do. So my y-intercept happens when x equals to 0. So I'm going to sub 0 into these 2 x's here. So I'm going to get that y equals to 2 times 0 squared plus 4 times 0 minus 3. And once again, that's just going to give me 0 and 0, because anytime I multiply by 0, I get 0. And I get negative 3 as my y-intercept. Okay, so Now we want to find my x-intercepts. And these happen when y equals 0. Okay, now we can use the discriminant just to figure out whether I'm going to have any intercepts to begin with. So I'm going to just really quickly substitute this into the formula of my discriminant. Discriminant equals b squared minus 4ac. So in place of the b, I'm going to put 4. In place of the a, I'm going to put 2. And in place of the c, I'm going to put negative 3. So that's going to give me 2 times, that's going to give me, my b is 4, so that gives me 4 squared minus 4 times a is 2 times negative 3. Okay, so that gives me 16, and then minus 4 times 2 times minus 3 is going to give me positive 24, and that is going to give me 40. Okay, so what does this tell me? My discriminant is greater than 0. Therefore, I have 2 x-intercepts. But the great thing about finding this discriminant is the discriminant is part of my quadratic equation anyway. So it's no actual extra work finding this because I'm going to be doing that anyway. So once I get this, I can sub this value straight into my quadratic formula. So for my x-intercepts, I get this when y equals 0. So I want to solve the equation 0 equals 2x squared plus 4x minus 3. And I'm going to find these, as the video says, using the quadratic formula. So using quadratic formula, x equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to pop in these values into my a, b, and c. And now, remember, we've already found the discriminant bit. That is 40. So I can just sub that straight in. But let's do this slowly. So here, my 2x solutions are going to be found using the quadratic formula. So substituting in 4 for b, I get minus 4 plus or minus the square root of 40 over 2 times 2. Okay, so I get minus 4 plus or minus. Now, the square root of 40, I can break this up into root 4 times root 10. Because remember, with surds, we can simplify these by pulling out the square root of a perfect square. And 2 times 2 gives me 4. And that gives me here negative 4 plus or minus. Square root of 4 is 2 root 10 over 4. And 2 can be pulled out of this entire expression, as well as this, it's a factor down the bottom as well. So this gives me 2 outside of negative 2 plus or minus root 10 over 2 times 2, or 4. And this 2 is going to cancel with one of the 2's down the bottom. So my solutions to the quadratic equation here are going to be that x equals to minus 2 plus or minus root 10 over 2. And remember, this plus or minus thing means that I have 2 solutions. One is that x equals to negative 2 plus root 10 over 2. And another is x equals to negative 2 minus root 10 over 2. So I have found my x-intercepts. And now we've been asked to round these to 2 decimal places. So I'm going to get that these are going to be approximately equal to 0.58 when you put this into a calculator, or negative 2.58. So this is to 2 decimal places. And okay, I found that. So I have my y-intercept, my 2 x-intercepts, as well as I want to find in part C my turning point. And my turning point I get when I substitute into this formula that we derived last time, x equals minus b over 2a. Now substituting in, my b is going to be 4, so I have minus 4 over, now 2 times a, my a is 2, so it's 2 times 2, and I get negative 4 over 4, which gives me to negative 1. Now, I have the x coordinate of my turning point. To find the y, I want to sub x equals negative 1 into my quadratic equation, my initial one from the question. So I'm going to sub negative 1 into, scrolling up here, subbing that into y equals 2x squared plus 4x minus 3. So let's see what I get for a y value there. I'm going to get here y equals to 2 multiplied by negative 1 squared plus 4 multiplied by negative 1 minus 3. And that, when I substitute that in, gives me a value of minus 5. So therefore, my turning point is negative 1 is at negative 1, negative 5. So we have all of our key ideas here. We have our 3, we call these significant points. We have a turning point, we have 2 x-intercepts, and we have a y-intercept. That is all we need to draw a rough sketch of what is going on. So we have y, we have x, and let me label in all of my points. So I have a y-intercept of negative 3, and I have a turning point at negative 1, negative 5. That's my turning point. And I want to substitute in, well, I want to mark in my x-intercepts. So I have one at 0.58, and I have one at about negative 2.58. Okay, now sketching this, I have a concave up parabola. Now, when I connect these dots, I'm going to see that anyway, but my equation was y equals to 2x squared plus 4x minus 3. And the way we can tell also that it's a concave up parabola is this coefficient of x squared is positive. So, sketching that in, I get this and this here. And I know that's drawn very badly. Apologies to anyone who had to witness that. But this is a sketch, a rough sketch. Remember, it doesn't need to be perfect. It's just a sketch of my parabola y equals 2x squared plus 4x minus 3. And we found this using 3 key ideas. We found this using our quadratic formula and discriminant. And our quadratic formula gave us our x-intercepts. We found my y-intercept. And we found our turning point via this process of finding the x-coordinate of my turning point, which is x equals minus b on 2a. and substituting that back into the equation of the parabola to find the y coordinate of that. Well, that brings us to the end of this video. Thank you so much for joining me, and I will see you next time.